Hello everyone, welcome back to my YouTube channel. I'm Pranati, currently studying in Sri Venkateshwara College of Engineering in the Department of CSE Data Science. Today we are discussing a topic in evolution of digital IC technology and its naming pattern. Let us see the introduction part. The evolution of digital integrated circuit IC technology has been marked by significant advancements over the decades, beginning with the invention of the transistors in the late 1940s, followed by the development of the first integrated circuits in the late 1950s. The journey of digital IC technology has been one of the continuous innovation. In the early years, digital ICs were relatively simple, consisting of a few transistors and diodes. However, as technically progressed, the number of transistors that could be integrated onto a single chip increased exponentially, leading to the development of one of the more complex and powerful digital ICs. IC circuit. Integrated circuit IC technology refers to the manufacturing and design processes used to create electronic circuits on a small semiconductor material, typically silicon. These circuits integrate multiple electronic components such as transistors, resistors, capacitors, and diodes. ICs can range from simple circuits with just a few components to complex systems on chip containing million or even billion of transistors. IC technology has revolutionized electronics by enabling the creation of smaller, more efficient and more reliable electronic devices. Early development of IC technology. The early development of integrated circuit IC technology dates back to the late 1950s and early 1960s. One of the key figures in the development of Jack Kilby, who working in the instruments invented the first integrated circuit in the year 1958. Kilby's invention was followed closely by Robert Noyce, who independently developed his own version in the year 1959. These early ICs were composed of a few transistors and other components fabricated onto a single piece of semiconductor material using silicon. Design of IC and types. The design of integrated circuit ICs involves creating complex layouts of electronic components such as transistors, resistors, capacitors, and interconnects on a small semiconductor substrate. There are several types of ICs, each serving different functions. Analog ICs. These ICs works with continuous signals and are used in applications such as amplifiers, voltage regulators, and analog to digital converters. They are crucial for processing real-world signals. Digital ICs. Digital ICs operate with a discrete level of voltage representing binary states zeros and ones. They include logic gates, flip-flops, microprocessors, and memory chips. Digital ICs are fundamental to computing the digital electronics. Mixed signal ICs. These ICs combine with analog and digital circuitry on the same chip. They are used in applications such as data conversions and sensor interferences and communication systems where both analog and digital processing are required. Application specific integrated circuits. These ICs are custom designed for specific applications and are optimized for performance, power consumption, and cost. They are commonly used in consumer electronics, automotive systems, and industrial control. Digital integrated circuit. A digital integrated circuit is a semiconductor device that processes discrete signals or binary data using digital logic circuits. This circuit consists of a transistors and other electronic components configured to perform the Boolean logical operations such as NAND, OR, and NOT gates. Digital ICs are designed to manipulate binary data represented by the voltage typical 0 volts and a higher voltage logic 1. Introduction to TTL. Transistor logic TTL is a popular family of digital integrated circuits that are widely used in the late 1960s and 1970s. Developed by the instruments in the early 1960s. TTL became the dominant logic family for many years due to its speed, versatility, and reliability. Evolution of IC naming pattern. The naming pattern for integrated circuits has evolved over time to accommodate the increasing complexity and diversity of semiconductor devices. Here's a brief overview of evolution of IC naming patterns. Early naming conventions. In early days of ICs, naming conventions were relatively simple and often descriptive. Numeric series. Many early ICs were assigned numeric part numbers, often indicating the functions or type of the devices. Alphanumeric part numbers. As IC technology advanced and more complex devices were developed, alphanumeric part numbers become more common. These part numbers often includes a combination of a series function and specific variant of the IC. Manufacturer-specific naming patterns. Different manufacturers often adopted their own naming convention for ICs, making it challenging to the part numbers across different product lines. Overall, the evolution of IC naming patterns reflects the industry's progression from simple functional descriptions to more sophisticated branding and marketing strategies, while still providing relevant technical information to the engineers. Totally the conclusion part. The evolution of digital IC technology and its naming pattern reflects a shift from simple functional descriptions to more complex alphanumeric codes and branding derived strategies. Initially, ICs were named based on their functions or component type, but as technology advanced, numeric designations and alphanumeric codes were introduced to provide more detailed information about the devices in recent years. There's been a focus on branding and marketing, with manufacturers using catch numbers and series branding to differentiate their products and create brand recognition. Despite these changes, the primary goal remains to provide relevant technical information to engineers and consumers of the context of a more sophisticated naming and marketing the framework. Thank you everyone.